So we're starting our new unit, which is the graphical model. So we're going to look at graphs. We're going to be able to interpret graphs, see what does the graph tell us, right? If we can find out what would the value be in so many years, right, by extending or the graph. So we have to look at trends in the graphs. Okay, in this unit, what we're going to do, we're going to learn how to use Excel to graph. Because when you go to college, they don't expect you to graph by hand. They expect you to use Excel or another graphing technology to graph and find a line of best fit. So I'm going to teach you how to do that using Excel and how to find the line of best fit, how to find the equation of the line of best fit using Excel. And hopefully that will get you ready for college. Okay. First, we're going to look at trends in graph, and we're going to analyze graphs by looking at them, what's happening, how do people use the graph in their daily life, right? We see that a lot in stock markets or in television, in data trends, in statistics, in all of these. They look at graphs and they analyze it, okay? So we should be able to do the same. So a graph is a visual representation. So which one is better? To look at a bunch of numbers, X and Y values, table of value from here to for 2 pages, or to graph them and then look at the trend? Which one is easier? The graph, right? So it's a visual representation of the relation between two quantities, right? We have the X and the Y value. It shows how one quantity changes with respect to the other quantity. So if I look at the first example, it's asking me to describe the relationship between shown in each group and be specific. So if I look at the first example, what I see is I have Jack's babysitting. So we have the earning as the y-axis and then the hours worked as the x-axis, right? So obviously your earning is going to depend on how many hours you worked, right? If you worked for 5 hours, you're going to get paid $50, let's say. If you worked for 10 hours, you're going to get paid $100. So it depends on how many hours you have worked. So it's a linear relation, yes? Because your rate is going to be the same. If you work 10 hours or 20 hours, it's going to be this much per hour. So how can you explain this to me? How can you analyze this to me? At a steady rate, yeah. And then as the number of hours increases, the number of dollars increases, so the earning increases at a constant rate, right? So exactly that's what you're going to have to say. So as the number of hours Jack works increases, his earnings so that word constant is very important, right? Because that describes the linear relation, right? That's what describes the linear relation. And then we see that as one increases, the other increases, so that's a positive increase, right? It's a positive. Amount of a compound interest investment, right? So we see that the amount is on the y-axis and the time that you put that money in the bank for is on the x-axis. So it depends on how much you put it in, then your amount is gonna depend on that. But because it's compounded interest, do you guys know what the word compound means? Compound means you're earning interest on the interest. Okay, so that means your interest that you're earning is not only on how much money you put in the bank. We call that simple interest because you're going to earn the same amount every single year or every single term. But with the compound, let's say you put $1,000 in the bank, right? And you earn 10% per year, compounded. So the first year you're going to earn $100, right, on the 1,000. So $100 on 1,000. So now you have $1,100 in the bank. That's after 1 year. For the second year, you're going to earn the interest on the 1,100. Not only on 1,000 anymore, you're going to earn it on the interest also that you have earned. Okay? So your interest is going to grow faster. Right? The interest that you're going to earn, it's going to go up faster. Okay? So that's why it's a small increase at the beginning, but then it's a fast increase after that. Have you guys watched that video where like they give you two options? Either you work, let's say at a McDonald's for 1 month, and then they'll pay you $1 million. Or the second choice is to work for a month, and they'll give you a penny to start with. You work for a month, 30 days, and then they will double it every day. Which one do you pick? Both you have to work for a month. One, you earn $1 million to start with, like they'll give you $1 million, or they give you a penny, and then they double on the first day of work, and they double it every day for a month. Remind me to show you the video. Okay? All right, and think about it in the meanwhile. All right? So here's the, what would you tell me about this? The amount is increasing with time. Yes, so as time increases, the amount increases. Is it increasing at a constant rate? No, it's increasing slower rate at the beginning, but then at a faster rate after that. Okay, so we're going to say that the amount of the compound interest investment increases over time. Slowly at first. So now I'm describing it. And then very fast. Are you guys okay with that? Okay, this graph is wrong. I copied the same graph. So the graph will look like, let's see, temperature of a cooling cup of coffee. Let's see, if you want to graph this, how would you graph it? What would you put on the X? What would you put on the Y? Time is at the bottom. Temperature on the side, okay. And how would that look like? Is it going to go down constantly, or is it going to go down and then slow down? So, and then it's going to keep going down? Until it gets to room temperature. So honestly, it's going to start that it's going to decrease fast and then it's going to slow down, okay? Because at first, this is hot. The room temperature is 20 degrees or whatever, right? And this is like almost 100 degrees, right? So what's going to happen is that there is a big difference. So they're going to exchange fast, the temperature, the heat, right? So it's going to decrease fast, and then it's going to slow down until it gets to room temperature, okay? So this is kind of the opposite of what we saw in the investment, okay? So the coffee temperature was going to decrease over time. Rapidly at first, then more slowly, finally leveling, off at room temperature. Are we okay with that? So then we're going to look at fertilizing a field. What we see here, we see a crop yield on the y-axis, and then the fertilizer used at the x-axis, or on the x-axis. So what we see there, we see a little bit of a kind of a quadratic, right? Not all of it. We see just part of a quadratic function, where we see a small increase at the beginning. It's going to reach a maximum value of the yield, but then the more fertilizer you use, the less yield you're going to have, is because a lot of fertilizer will ruin your crop, okay? It will cause burning and whatever, right? So it's going to ruin your crop. So what we see here, we see a small increase, and we see a greater decrease when after you get to a maximum value. So as fertilizer use increases, the crop yield also increases. To a max. And then